Hey guys, so this is going to be the third video going over problem number 3 in the Biweekly 52 contest. Um, this is rotating the box. Um, yeah, so I'll be going over the problem and then going over the solution that I came up with during the contest. And so in this problem, you're given essentially a matrix representing a box, and in this box there can be rocks, a stone, an obstacle, or just air, so it's empty. And so what they want you to do is they want you to rotate the matrix 90 degrees and then return what it looks like. And each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. So essentially what it's saying is these stones will be affected by gravity, but these obstacles will just kind of stay there as like a platform. So if a stone falls down, it can only fall through these air blocks. If it sees a stone or an obstacle, it'll stop. Or if it just hits the floor, I guess, which is like this last row here. And so, yeah, I don't think there's anything else too important in the problem. Yeah, and you're supposed to return the matrix representing the box after the rotation occurs. So just going over some other test cases here. If the box looks like this, so a rock, some air, and then another rock. If you rotate this 90 degrees by rotating it, and then this stone on top here will fall down and land on top of this stone on the bottom. And in the second test case, these are just obstacles. So when it rotates 90 degrees, these two rocks here will end up here, and they won't be really that changed, but this rock here will end up here and then fall down due to gravity and land on this obstacle. So yeah, that's about it for the problem. So yeah, so let's go over how to solve this. So there's essentially two parts to this problem. There's the part where you need to rotate this box that you're given, and then after you rotate it, you need to go through and basically simulate the effect of gravity and pull all the stones down. And so yeah, I'll go over the first part right now. So you rotate this box essentially just by let me figure out how to explain this. So when you rotate a box, it is important to observe that this top row here will always end up as the rightmost column here, because if we have like a box here and then we have like a row here, when we rotate this, see this column right here, this row, when you rotate this like that, like if you rotate this whole thing, like you can tell what I mean, right? Here, I'll just cut this out of the video, and yeah, okay, so when you have a box like this and then you rotate it, so like this, what used to be the top row here now becomes this column. So instead of reading the numbers like this guy, this guy, this guy, this guy, this guy, these will essentially translate to this guy, like that. And then same with the second row here, that'll just be this column. So for like 1, 2, 3, 4, this column will be 1, 2, 3, 4, and then etc. So another guy, another row, that'd be this column, and etc. So essentially what you can do is you can just loop through all the rows here, and so you know this, if this is row number like 0, you'll know this corresponds to this column, which should be the length of this like row, which I guess we'll call like the number of columns there are. So the number of columns in this table, in the rotated table, will be the number of rows in this original table. So yeah, so this guy here will be the number of rows in this table, which we'll just call like n. This will be n minus 1 minus 0. That's the index of this column. And of course, the row will be whatever this number is. So this will be the first number in this index. This will be, this row. So this is the 0th index. So this is the first element in this row. This is the second element, and this is the third, and etc. And so this index here, so this is the 0th index, that'll correspond to the row here. So this will be the 0th row, first row. So essentially what we can do is here, this is the phase where we rotate it. So we have the box here. So I create a new like 2D array where so here I save the height of the box. So this is how many rows there are going to be. So that's like 0, 1, 2. And here I save the width. So this is how many things are in each row. So how many columns. And so I initialize a new array with the dimensions just reversed. So however many columns there were in this box will be the number of rows I have in this box, and however many rows I have in this box will be the number of columns because of how we rotated this. And so then I would just use 2 for loops to loop through. This is for every row in the original box, and this is looping through the columns within that specific row. And so that will be this element here. So it'll grab this element, then this element, then etc. And then I know I need to put them here, 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 and etc. And then here again. So I know that the column I need to put this in will be so let's just call this like row R. The column will be the length minus 1 minus R, because that's the index of the column, and the row will just be whatever column is in this one. So this is column 0, 1, 2. This will be row 0, row 1, and you're going to move downward in the rows. So that's exactly what we have here. So this J will increment through this array. So J will be here, then here, then here. We'll have that be the row, and then this would be the column, which is of course the number of rows here, which, and then minus I minus 1. So that's the index of the column. So then we just set that equal to whatever we have. So after this chart character array will essentially be the rotated version of our box. And then we will move on to the next phase, which we essentially just loop over all the things inside of our rotated array. So let's just say we have like a rotated array that looks like this, and we have some stones here that are just kind of floating. So what we can do is we can loop through each column. So for every column we can start at the bottom row, and whenever we see a rock, so let's just say this rock is here, we pull it all the way down until it hits the floor, it hits another rock, or it hits an obstacle. So essentially what that means is as long as there's air under it, which is represented by a period, we pull it down. And that's just a simple matter of swapping these two elements. So yeah, so here we look, if there's a rock here, okay, sure, it's already hitting the floor, so we don't actually pull it down at all. And then we check this one, there's not a rock there, so we check this one. We notice in this specific case here, let's just say there's air under it, we will swap it with this, and then while there's air under it, this is pseudocode of course, while there's air under it, we swap it down with the air and make it just essentially fall down. So then essentially we'll make this rock fall all the way down to here. And that's pretty much it. So then you do this process for each column. Starting from this column, it doesn't actually matter. You could start from any column. You could start the other way around. But yeah, you check this column, and check this column, and then it's important to start from the bottom, just because that way you can always pull a rock all the way down until it hits like a solid object. So that's pretty much what I do here. So this represents how many columns there are, because the result 0, that's just how long this array here is. So that's representing the number of columns. So I go through all the columns, and then so this will go through all the rows starting from the most bottom row. So it'll start from here, and it'll go up by subtracting. And so if I detect a rock here, I just make a temporary variable representing what the row is under this rock. So if I detect this row, let's just say arbitrarily this is row number 2. If I detect a rock at row number 2, I want to check row number 3 to see if there's air here. And if there is, I'll perform the swap by pulling this guy down. And so that's essentially what this does. So while the thing under it, so remember I is the column, so while the thing under it is air, and it's just worthwhile to check while the thing under it is also within the bounds of the array, because if I know this is the very bottom one, the thing under it will be here, that's out of bounds of the array, so this will throw an exception. But also in this problem, being on the bottom represents that you can't be pulled down anymore. So these two checks here, if they both pass, then that means there must be an air thing under it, which is a period. We just pull it down. So this performs a swap between those elements. So it makes this guy here a period, and it makes, let me just draw that better. So it makes this guy here, a period, and this guy here number sign. And yeah, so after doing that for all the columns, simulating the effect of gravity, you can just return this new box. And yeah, so just submit it to prove that it works here. Yeah, I'm pretty sure this was this isn't exactly the fastest, but I'm pretty sure that's because there might be a way to simulate gravity better, but at any rate, this solution was really easy for me to understand, and as long as it works, because that's the only thing that matters in the contest. So yeah, that's the end of the video, describing the problem, rotating the box. I hope you guys enjoyed. I'll be back with another video tomorrow.